Alright, I'm back for what's hopefully a short video on adding a 3-part jump loop to Gait Locomotion System, or a layered animation system. So it's going to start off with your animation layer interface, as most things will in this. And we're going to add a jump start state. We will add a fall loop state. And then we're going to add one called additives. And this is not going to make sense at first, but it will later. Sort of. Okay, so we have those three. And then when we open our thing up, now we can see that they've appeared in our layer interface, where we're going to, or our layer instance, where we're going to add our update stuff. So now I feel like I'm drawing a blank, but I'll remember. If I go jump or sequence, and this is going to be set to jump start. If I go to our fall loop, should be set to our jump fall loop. And then our additives are going to be set up differently. So I believe that's all you have to do with those two. So play rate, start position, everything else should be good. And then we'll have to do our additives layer. So when we get to our additives layer, I'm just going to show you the example blueprint, because it's going to be a lot easier for me to iterate and show you what's going on without me having to sit here and build it. So we just build a state machine. That state machine has one transition per frame. The identity pose is just nothing. This is sort of like, call it a conduit, but not quite. In this, it's just going to say, I am not grounded. And if I'm not grounded, it's going to be an error identity pose, which looks like nothing. You could put additive stuff in these, but they don't have any additive to add to them right now, so there's no point. It's something I'll expand later. This will then go is grounded. So when you're grounded, you'll do your landed recovery. Your landed recovery is going to be an additive identity pose blended with your jump recovery additive. So it's going to be kind of like your current pose blended with the jump recovery additive, and then it's going to do a on become relevant set up land recovery. So I could sit here and write all this by hand, but to make this video shorter, I'm just going to copy and paste this from this example, because I'm in the example project. And you can do the same thing if you want. And it should just copy over without any compilation errors, but I'm just going to really quickly double check. Nope, because it needs that on become relevant. So set up land recovery is what it's going to be called. I'll remove the binding, create a new one. Set up land recovery. And as I showed you before, because I didn't do any spaces, I now just have to go through and do that. And I'll set up land recovery. And remember, you can call the function from the wrong spot, or you can call it from the Gait Locomotion System anim functions. So we have that. And if you want, you can read what it says. It just says set land recovery alpha. And I believe that is set through predictive landing through the CMC. So it might not act like it's supposed to unless I change the CMC over, but I'm going to do that right now anyway. So we have that. That's all set up properly. Again, it's just blending with the land recovery alpha. And this could be more complex, but it's not. Then this just automatically transitions or is not grounded, you know. So it'll go back through those things if you're not grounded, or automatically. The second one is simply just an automatic transitional rule, and it's priority 2. Because otherwise, if you're doing this, you want to do it quicker. Okay, that being said, that's how you set up the additive state. So it's just the additive state machine, one transition again. The jump state, it's just jump start, or jump start state. And then the fall loop state is just like that. So you've got your layer now set up. After that, we're going to bounce back to the main anim instance. So this is going to be where our locomotion and our inertialization is occurring. And inside of here, we're going to add our new stuff. And again, I'm just going to copy this over from the very basic one, because it's a lot easier for me to copy and then explain than it is for me to write it from scratch. But if you're going to write it from scratch, it's just as easy as this is a conduit, this is a state, this is a state alias. So if you hover over top of these, you actually have to click on them. This one you can see is an alias. So any of the pink ones are going to be alias, any of the green ones are going to be conduits. Conduits are kind of like a switch on a railway track. Alias are more like a gateway. So if I want to enter in air, the only way to enter in air is from idle or from cycle state. If I am grounded, I can only enter grounded from jump or fall loop. If I want to enter cycle, I can only enter cycle from, this is supposed to say cycle, I'm pretty sure. Yeah, cycle and idle. Oh, it's because I copied them. Maybe not. Figured it would be because I copied them over, but yeah, anyway, these should go to cycle and idle appropriately, and then those will act as gateways back to these. So how this is all working is when you're in air, again, you're coming from either idle or cycle. And then if you're jumping, which means your Z velocity is greater than 0, that means you're in jump start. So if you're in jump start, this is the wrong anim interface. We're going to go ALI. Actually, it's going to go jump start, and it'll come up right here. This is going to say basic anim interface, as we remember that's the one that we're using, not the other one that's part of the example project. Compile, and then we're going to get an error about the other one right here, because again, we don't have this interface. And fall loop state is now the basic anim interface. Solved. Okay. So that being said, again, if we're jumping, our Z velocity is greater, so it's going to go to jump start. Jump to fall is going to be an automatic transitional rule because you are going to be falling once the jump start animation ends, and that'll enter fall loop. And then fall loop is automatically just entered if you're falling, so if you just walk off an edge, it won't play the jump animation, obviously, because your Z velocity is not greater than 0. Once you enter grounded, it's going to end in air, and it should do this automatically, I believe. Oh, it's just just transitions automatically to the conduit. And the conduit will say, if you have acceleration, you're going to enter cycle because that means you're still walking. So again, if you jump and maybe you release input, but your friction isn't super high or something on your character movement component, your character will probably still take a few steps after the jump because of the velocity that they have applied to them. Or this will just automatically enter if, as a priority order 2, if the cycle doesn't go off. So that's basically how you do that. And then the last part of it is we just have to add the animations to our unarmed. So we have MM unarmed here. And then in our anim set, we have our jump. So we're going to go MM unarmed jump. This is just the third person animations retargeted. So actually, they're not even retargeted. These are part of the example project. Like, you know, the default Epic Unreal project. And a lot more animation packs use this like 3-part loop, which is why I wanted to include this in this series, is because a lot of animation systems don't need a 5-part predictive landing loop. Like that, it's just kind of overkill. It's good for a player, but it doesn't. It's totally unnecessary for AI. So yeah, MM jump, fall loop, and then the land is an additive. And the land becomes an additive because it's sort of like the impact of when you land. So this will blend into your locomotion and all of that other stuff when it's an additive. Whereas if it's your landing animation, it won't blend quite as pretty. So we do that. And then we should have a working jump. And it looks all good. So yeah, again, the upside to doing a simpler system like this is that if you were to check the performance of it is going to be a lot quicker than if you have like tons and tons and tons of animations. And the great thing about doing layering is that this layer has however many animations now, and the size map is still, the disk size shows all the animation size. So this is showing all the animations that are being used, but the actual memory size of this is only 1 megabyte, which is very little. And as you expand this, because it's going to like load a lot of these references pretty easily, then it's going to keep it to the imprint very small. And if you really wanted to be granular about it, you could convert these to soft references through whatever you're using. So let's say, for example, you have a ton of animation layers and a ton of different weapons. And whenever you pick up a weapon, it would have a soft reference within that weapon's data to the animation blueprint that it's going to use, the animation layer. And then when it initializes and links that layer, you'd have it load this class from a soft reference using async load. The thing is that you can't have an async load or an async load class. You can't have these occur within a function, and I'll talk about this in some other stuff. You can have them occur in functions in C++, but not in Blueprint. So that means that you would have to run them like in your event graph or something like that in order to do this, but it is totally possible, and I've done it off of stuff before without hitching. So that's where I'm going to end this video. Pretty sure I covered everything. Fall's looking good. Feel free to like lean on the example content, because a lot of this example content is going to cover like a bunch of cases, and as this gets further on, I'll cover more and more cases, try to comment it as much as possible. But the important thing is to kind of just track down what you're trying to get achieved and look at the little markers along the way in any of these certain blueprints. You know what I mean? Like what update functions are being run, what on become relevant functions are being run. And if you're ever wondering what they're doing, just hover over top of them and it's just going to say in the description. So it makes it a lot easier. And then my next plan is to kind of go over and comment every single blueprint. So when you hover over the blueprints, even, it will give you a in-depth description right over top of them. So yeah, I'm going to end this video now. Like and subscribe if you like it, and hopefully check out the plugin.